Hello everyone, thanks for joining today's Micro Minute. My name is Holly. I'm an XRM application engineer at ZMCC in California. So today I will show you how to use our Versa XRM 730 to image high aspect ratio samples, such as the PCB I'm going to use today. So for high aspect ratio samples, usually it's very thin and white, such as your cell phone or power cell batteries. So usually when we image sample with X-ray system, we need to rotate the sample to collect 2D projection images at a different angle, and then use a reconstructor to reconstruct this 2D projection image together to generate the 3D data. So different with the cylinder or cube shape sample, when we rotate the high aspect ratio sample, we will have a short view and a long view. So for the short view, there will be less material to penetrate by the X-ray, and for the long view, there will be more material need to penetrate by the X-ray. So which will result to low signal to noise ratio when we have the long view, and also the streak artifacts. So because it's different, to set up scan for high aspect ratio sample going to be different with the scan setup for like cylinder or cube samples. So today I'm going to show you how easily we can set up scans for high aspect ratio samples with our Versa XRM 730 systems. And this is NavX, the software we use to control and set up scans for 730. And you can see this part, the top part, shows the status of the whole system, and the left part shows the whole workflow. So usually we need 5 different steps to set up scan. And it's very easy to set up scan. So first of all, we just need to select a folder to save the data and input the sample name. And then we can load the sample by either an autoloader or just manually load the sample onto the sample stage. And the NavX also give us a lot of like a tutorial, like a sample mounting tutorial. So you just need to let the system know your sample size, sample shape, and the sample density. So it will give you a lot of recommendations, such as what kind of sample holder you need to use and how to mount your sample. So after we mount the sample, we can just use a Smart Shield or Smart Shield Lite to generate a digital envelope of your sample. So if your sample doesn't work with Smart Shield, you can use a Smart Shield Lite. So Smart Shield is an automatic method. So you don't need to do anything. It can generate the envelope automatically. But for Smart Shield Lite, it's a manual method. So today we're going to use Smart Shield Lite to generate the envelope. So at the beginning, the system is going to move the source and detector far away automatically. And then we need to manually move the sample, the holder, and the base into this green box. So for now, the sample looks a little bit low. So we move it up a little bit. And also we need to rotate the sample 360 degrees to make sure it's always in the green box. And then we can manually create the envelope now. So you can see we have 2 blue bounding boxes. So we can use the bottom one for the sample holder and the top one for the sample itself. So we need to make sure the sample holder and sample is always in the bounding box when we rotate it. So you can, when we rotate to -90 degrees, we can just resize it to make sure it's always in the box. So after we confirm, we can just generate the envelope. It only takes 1 second. And after we generate the envelope, first of all, we need to verify the boundary of the envelope. So we rotate the sample to make sure it's always between these 2 lines. And then we can change to system model view. So this is a digital model, the digital envelope we just created. So you can see the shape is very similar to our sample. So with the help of the digital inverse model, so when we move the source detector and the sample, it will prevent the collision between each other. So for ZEN NavX, we have 3 different ways to set up scan. So you can set up scan manually, just like other X-ray systems. And also you can use a 3D volume scout and 2D projection scout. So the difference between the 3D volume scout and the 2D projection scout is that if your sample is very complicated and it's very hard to locate your region of interest or features from the 2D projection view, you can use a 3D volume scout to run a very fast scan, quick scan, like a 1 minute or 2 minute scan, and then by using the 3D data to locate your region of interest or feature. So if your sample is very easy to figure out where is your region of interest or field view from the 2D projection view, so you can use a 2D projection scout. So for the sample we use today is a PCB board. So it's pretty easy to locate our region of interest. So I'm going to use a 2D projection scout today. So first of all, we're going to adjust the vertical position of the ROI. So you can move this crosshair up, down to locate your region of interest. And then we can just click go, so the source and detector will move accordingly. And then we turn on the X-ray and collect 2 2D projection images at both 0 and -90 degrees. So we're gonna use these 2 2D projection image to locate our region of interest. Yeah, so we rotate and take an image again. So this is -90 degrees. And we go to the next step. So we can see these 2 2D projection image at the same time. So you can see there's a blue box. This is our ROI2. So we can just resize it and move it around to locate, to select our region of interest. And after we select our region of interest, NavX is going to give us parameter recommendation. So first of all, it will recommend which objective you can use to cover this field of view. So for the NavX, for 730, so for VEISS XRM 730, we have different objectives. So you can have flat panel 0.4x, 4x, 20x, and also 40x prime. So we use different objectives or detectors for different resolution on different size of field of view. So for this field of view, it recommends me to use 0.4x with a binning 2. So, but I want to get a higher resolution, so I change the binning to binning 1, so I can get higher resolution but still keeps the field of view size. And after we decide the objectives, NavX is gonna give us a graph like this. It shows the relationship between the resolution, the scan time, and also the field of view. So when I move this Y line left and right, you can see how the scan time and the resolution changed. So when I move to the left, the resolution is going to be higher, the field of view is going to be smaller, and when I move to the right, the scan time going to be, the field of view going to be larger, but the resolution going to be lower. And also you can see how the scan time changed. And after we confirm the field of view, we can go to next step. So next step, it will check all the parameters for us, such as the exposure time, the filter, the voltage, and the projection numbers. And to set up scan, so we need to collect a reference image. And if you already know how to move your source, how to move your sample out of the field of view, you can just select the reference collection direction. But if you are not sure, you can just select I'm not sure, please guide me. So after we click start, the NavX is gonna move the source and detector to the position and also gonna ask a few questions. So first of all, it will ask you, is it an internal tomography or full field view? And then it will ask you is your how looks like of your sample. So if it's like a flat sample, it asks you to rotate your sample to 45 degree or minus 45 degree to collect a 2D projection image. And then the system will use this image to check the transmittance value and also the intensity value to decide all these parameters. So we rotate to minus 45 and collect an image. So after that, it will start to check all the parameters. So it will start with 80 kV and take a reference image, ask you, can you see your sample in the field view? If you know, click no. So it will know it can move the sample out of field view in this Y direction. And after that, it will check the transmittance value to decide the filter. And then if the transmittance value is too low, it will increase the kV, so voltage, to make it higher. So usually, in order to get high image quality, we need to make sure the transmittance value is between 20 to 35%. So it will adjust the voltage accordingly. So it will check different kV and check the transmittance value and also the intensity value. So after all of this, it will give you 3 recommendations. So you have 3 recommendations. One is better image, one is balanced scan, and one is the faster scan. So you can say for better image quality scan, it will use a lower kV because lower kV gonna give you better contrast, but the scan time gonna be longer. And by increase the kV, the scan gonna be faster, but the contrast gonna be lower. So you can also check this 2D projection image for the same location to compare with each other to decide which one you prefer. So after you select which one you prefer, you can just update it and go to next step. So usually when you image samples, you need to rotate 360 degrees, but for flat sample, we only use 180 plus phi angle. So you can say the angle range already been set it up to 180 plus phi automatically because we use smart show light, and by checking the shape of the digital envelope, the system already know it's a high aspect ratio sample. So it will set it up by itself automatically. And also for high aspect ratio sample, we have 2 other methods, 2 different methods to increase the image quality and or to reduce the scan time. So one is high aspect ratio tomography, one is variable exposure time method. So for variable exposure time method, because this is high aspect ratio sample, when we rotate, we're gonna have long view and short view. So if we use a constant exposure time, when we have the long view, the intensity value gonna be very low, but when we have the short view, the intensity value gonna be higher. So which makes at the long view, the signal to noise ratio gonna be lower, and also we're gonna have like a photo starvation effects. So in order to solve this problem, we change the exposure time, and we increase exposure time when we have the long view to make sure the intensity value is still enough. And for the high aspect ratio tomography, it's a different methods. So we keep the exposure time constant, but change the projection angular density. So we collect more projections when we have the long view. So by using the high aspect ratio tomography method, we can collect better image quality with the same scan time, or we can have the same image quality but reduce the scan time, make the scan faster. So this is the two different ways. And also for these two different methods, it's very easy to set it up. So for high aspect ratio and variable exposure time methods, you just need to let the system know where is the long view. So for this sample, the long view is at minus or positive 90 degree. And also you just need to check the ratio between the long view and the short view and put it in, input it. That's it. And then you can just start the scan to collect the image. And this is the result we collect for the same sample with different methods. So this is how the image looks like for a common setting. And this is how it looks like with the HART methods. And this is how it looks like with the variable exposure time methods. So let's zoom in to have a closer look of the data. So this is how the common setting looks like. And this is how it looks like with HART. So you can see with HART, the middle part looks smoother with less noisy, right? And also you can see the contrast between different material phases looks better. So same thing with the variable exposure time. So with variable exposure time, the contrast looks better and the image looks less noisy. Okay, so please let me know if you have any questions. Okay, yeah, so this is three of QR code. So you can just you can use these three QR codes to check the upcoming ZMCC workshops and also the upcoming live streams. So we will have the Micron Minute every week, Thursday at 1 p.m. Okay, thank you for joining today's Micron Minute. Have a great day. Thank you. Bye.